Hi guys, welcome back to the CS Classroom. Today we're going to learn how to make an animated line graph like so. Now, this can be useful for displaying real-time streams of data like music that's playing or stock information or anything that's changing at a very rapid pace and coming from an external source. Now, this particular graph comes from a website called Trinket where there are quite a few tutorials. I've kind of repurposed it for this tutorial. Now, what this right here, this bar right here basically allows us to change how often this graph is going to be refreshing, and pixels per sample basically allows us to change the distance between each point, basically the distance between each point on the graph that's being displayed. Now these are mainly basically to show how we can control this particular graph. Now I'm going to go ahead and close this because it's super distracting. We will come back to this once we have finished writing some code. Okay, so right here what I have is a screenshot. So we can kind of use that to describe what the code is doing. And let's go ahead and get started. So first we're going to do import PySimpleGUI as SG. As usual, then we're going to do from random import randint. And the reason we're doing that is because right here we're just generating random points. Now, if you had an actual data source, your points on this graph would correspond to, I don't know, an increase in stock price or an increase in the frequency of a song. But here we're just going to be generating random points. Now, next what we're going to do is specify the size of this graph. And so we're going to say graph size equals 400 by 200. Then we're going to have a sort of default graph step size. And that's just going to be how many by how many pixels we progress as we go through the graph. And that's just going to be a default that we're starting out with. So now we're going to go ahead and we're going to just specify this theme, which is going to be light green. So we'll say sg.change look and feel light green, which is basically giving it a theme. And then what we're going to do is we're going to say layout equals sg.graph graph size, which we specified up here. The coordinate, the leftmost coordinate, and the rightmost coordinate. So basically right here, we're going to be using a graph element, which is very powerful. It basically acts as a canvas, and it allows us to draw things in this particular area right here. In this case, we're just going to be drawing lines on a graph. And what we're going to do is basically right here is we're specifying the canvas size, the bottom left coordinate, the graph, we can say graph bottom left, because that's the name of the parameter, and then graph top right. So that's what we're specifying right here. We're going to follow that up by specifying a key. The key is just going to be graph. And then we'll say background color equals light blue. It's giving it that light blue color back here. So next, what we're going to be doing is we're going to, well, also just to rehash or just to review, remember this layout is going to be a 2D array. So actually what we do need to do right here is we need to have that bracket right there. So this is going to be one array, and that's going to specify this row or this graph. Then we're going to, basically, we're actually going to create these options. Again, we're just going to be replicating whatever is right here. So we're going to say sg.text. Apologies for my spelling. Milliseconds per sample. And then size 21. It's going to be the size of the text element. And we're probably not going to close this off quite yet. We're going to just have a comma right here. And then we're going to have sg.slider. So sliders is specifying this right here. That slider is going to go from 1 to 30, or 0 to 30 rather. Default value being 15. It's going to be horizontal, so orientation will equal h. And then the key will equal delay. So again, this is how many times we're going to be refreshing this particular window. All right. And next we're going to be creating this. So we can actually just go ahead and copy this right here and just make a few changes. This tutorial isn't really focusing on sliders. And right here we can say pixels per sample. This one is going to be 1 to 30. Can't really progress by 0 pixels. Remember, this pixels per sample is basically what the difference is going to be between each point, what the horizontal difference in terms of pixels is going to be between each point. It's going to be 130. Default value is going to be graph step size, which we specified right up here. And our key is going to be step size. With an underscore. So I think that should do it right there. I don't think we really need this comma. We'll also have just a simple exit button. So I'll have sg.button and then exit. So we're going to create a window to hold that layout. We'll say window equals sg.window. We're not really going to have any fancy options right here. It's just going to be animated line graph example. And then we'll take the layout in. We're going to specify a few variables right here before we go to the event loop. So we're going to say delay equals 0, x equals 0, meaning the x coordinate of a given point. Okay, I'm terrible at typing. Y equals 0. We're going to have last x equals 0. And all right, that should probably do it. Well, actually, probably we're not going to specify y at this point, but just x, because we're moving in the x direction. And the y is going to be generated randomly. And now let's move on to the event loop. So we're going to say while true, as always, and we're going to have event values equals window.read, timeout equals delay. So you'll kind of see where this delay comes into play right here. All right. So we're gonna have if event in none, exit, just allowing us to go ahead and exit out of this loop if we need to. And then we're gonna have step size. So for now, right now, this right here, this timeout is 0. So that means it would just be progressing as normal, which there wouldn't actually be any movement. But we're going to have step size, or rather, we would just be executing the event loop based on individual events, not repetitively. So we'd go through the while loop. If there were any events, we would go back to the top of the while loop, but we wouldn't be we wouldn't have a timed execution of this event loop. But here we're going to have step size equals values, step size. Actually, we'll put delay above that just because that's the way it's in the UI. And then we're going to have okay, that should probably do it right there. Okay. And then we're going to have delay equals values delay. And you can see that based on these keys that we specified right here, this delay is going to be corresponding to this bar right here, and this step size is going to be corresponding to this bar right here. Now, next we're going to get our y value. So we have our x value, which is at this point is just going to be 0, which is just going to be, right down here. Well, it's going to be right here at the beginning. So this is before, we can assume this is before the graph even really starts functioning. And then, obviously the x will change, but the y each time is going to be some randomly generated number between our height, which is 400. So between 0 and 400. Or sorry, between rather our y, which is 200. So it's going to be we're going to have some value between 0 and 200 right here. This is 400 pixels wide and 200 pixels high. So we're saying y equals rand int 0, graph size 1. And this graph size 1 is referring to right here, graph size 1. And we're randomly generating a number between 0 and 200. And then we're going to say if x is less than graph size 0, do something. Else, do something else. So I kind of just stopped right here because I want to specify what this means. So right now we're saying if x is later than 400, or is less than 400, not later. So let's go ahead and let's run our demo application again and see exactly what that means. So we're going to run this. Okay, I'm going to run it again. So right here, see, right now it's running and then it started moving. Before it starts moving, when it is running, so that's just going to be this right here. So I'll run that one more time just to give you an idea, because I couldn't catch it. It's actually pretty quick. All right, have this right up here. We'll run this. So right here it's 4. Okay, see there it got to 400, and that was before the screen started moving. So this x is less than 400. That represents what we're going to do, how we're going to display our points before the screen starts moving, before the x value gets greater than 400, and we need to move this graph to show the current points that are being displayed. So this is the beginning, and this is going to be after the graph moves beyond 400 pixels. So right here, basically what we've got is we're going to say window graph, and this, well, let me go ahead and type that out, but I just want to make it clear that this is referring to our graph element. So this is referring to our graph element right here, or which is specified right here in our layout. So we're going to have window graph dot draw line. Remember, this graph element is used to draw things in PySimpleGUI. Last x. So we're basically drawing a line between two coordinates in the graph element, last y. X, y, width equals 1. So right here, we're basically drawing a line to start out with from 0, 0 to whatever x we have. And we'll change the value of x later to whatever x, y having been randomly generated, and x, which we'll see later. So we're going to start out by just drawing a line from 0, 0 to our first point, and we're going to keep doing that until x becomes 400. Okay? And the width of that line is just going to be 1. So that's how we're drawing a line here. Now, once we get beyond 400, our behavior is going to change a bit. So we're going to say window graph dot move negative step size zero. So basically what this is doing, so this step size is coming from right over here. So this is coming from this slider right here. And for example, if this is at 5, that means that each iteration, each time you move, so for example, in this case, every 15 seconds, we're going to move the graph forwards by 5 pixels, by whatever step size we've specified right here, or is being specified right here. So this is actually moving the graph. And let's say, for example, if our step size is 5, this is going to be dot move -5, 0. So this is essentially moving our graph forward by 5 pixels. So it's not drawing, it's just moving our graph. But also, after that, as or after that is moved, we still need to draw a line. So we're going to say window, graph, dot draw line. And that's going to be from last x, last y, x, y, again with a width of 1. And we still haven't changed the x, we'll get into that, as well as last x and last y. So what we're going to do right here is we're going to say x minus or x equals x minus step size. Remember, this is our step size being taken from right here. And this isn't very intuitive as to why we do that, but in a second you'll see why. Then we're going to get out of this if statement, and we're going to say last x, last y equals x, y. It's basically changing this last x after all of this, after the point has been, well, after the line has been drawn. So for example, if last x, last y is drawn from 0, 0 to whatever this is right here, which is going to be our xy, then our last x, last y becomes the last point. So if we're drawing a line from right down here to right up here, then the new last x, last y will be this point right after here. So this is the last point, or this is the last point to which a line has been drawn. And additionally, we're going to do x plus equal step size. What this means is that when we're going from 0 to 400 pixels, our step size, our x value, so our x coordinate is increasing by whatever the step size is each time. And when we're actually moving the graph, the step size is basically staying, or x is basically staying the same. So we're basically staying in the same place. We are just moving the graph, and we're drawing a line from our last x, last y to the same x coordinate, but with a different y value. So essentially what's happening right here is our x coordinate. So once we get beyond the 400 pixels, our x coordinate staying the same, and we're just moving this graph. Versus before we get to the end of the frame, the 400 pixels, we're actually moving our x coordinate until we get to the maximum graph size, which in this case has been specified as 400. So here we keep drawing, but really the x value is staying in one place. We're just moving the graph. And here we are actually moving the x coordinate until we get to 400 pixels. And that shows sort of a randomized graph with movement forwards. Once we've done that, we can just do window.close. So that's actually kind of a way that you can display any set of data or any points in a timed way. Now, you remember this delay, we had timeout equals delay, and that started out as 0. But that was changed by this slider right here. So we could say refresh this, so plot a new point every 15 milliseconds, or every 30 milliseconds, or every 1 millisecond, whatever we really want to do. Now, let's actually just go ahead and run this and do some troubleshooting before we talk about the next steps. I'm going to clear this. Exit out of this. Do I have anything else running? No. All right. Okay, we have a little error right here. It says list indices must be integers or slices, not button. Probably means that we've got something going on right up here. It's going to be on line 15. Let's go troubleshoot. Okay, usually this means there's something wrong with parentheses or with braces. It's just always a pain. Deal with this. Okay, we've got sliders. That looks good right there. Okay, we need a comma right there. That's what it is. Cool. Let's go ahead and put this back down. All right. Cool. Let's try and run that again. Okay. So it's going a little bit slower, refreshing a little bit more slowly. Right here we have more pixels between each point. So that means the step size is larger. Right here we have almost no time in between points being plotted. And we've got super small points as well. So we're just every 1 pixel we're graphing something, and we're refreshing it really frequently, showing a chart like this. Now the point of this is just to show how you can kind of position different points on your chart. Going forward, probably the next tutorial I'm going to make is going to be getting real-time stock data via an API and using threading, and then displaying that in a graph like so. Anyways, if this has been of value to you and you want to see more videos like it, please remember to like and subscribe to the channel. There'll be a link to the code in the description, and that's going to come from trinket.com. So I just want to give credit where credit is due, and you can find the code for that there and check out any other tutorials that might interest you. Have a nice day.